Okay, here we go. So, what is it? Septiembre 26? ¿Sí?
Siete.
Siete. I said seis, siete, sí. All right, so Septiembre 27. Okay, so our objective today really is going to be synthetic division. It really only works on some x minus some number or x plus some number, okay? It will not work on anything else, but it's such a slick way to do things. So we just learned the remainder theorem, and that is if P of A is equal to 0, then we know that x minus A is a factor, okay? So then we know that if I were to put in -3 into here, and +3 in here, whatever I get, if I get 0, it's a factor. If not, okay. So actually I said that backwards. So P of A will determine the remainder. If you divide by x minus A, you put P of A, it'll tell you the remainder. That's all it is. Okay? So, in this example, if I've got x minus 3, and if I set it equal to 0, let's just start here on example 1. If I set it equal to 0, then we could solve and say x is equal to 3. So that means that, in a sense, this is an x value somewhere on this curvy line. Does that make sense? Right? 3. And what's the corresponding y value? We could plug it in, right? To get the corresponding y value. If we plugged it in and I got an answer, that would be my remainder, which would be some point on the line, okay? If I plug this in and got an answer of 0, then we know it's an x-intercept. That makes sense? An x-intercept, which means it's also a 0, okay? Now, we want to divide, but we want to do synthetic division. So we're going to start with 3. It's always the opposite, okay? Okay. Do an upside-down division symbol because we're doing synthetic division, okay? We're going to put the coefficients in. We're going to be careful on this one. We're not going to be tricked because we're going to put a 0. We're going to go 2, 0, because there's 0x cubed. Everybody get that? You have to have a place value there, okay? 2, 0, -15, -10, and 5, okay? Everybody good? So you just put the coefficients. Don't forget 0 is a place value for the cubes. You have to have it there. Just like regular numbers, if I had, let's say I had 2031 or, right, different numbers. Agree? Totally different numbers. You have to have a 0 for that 100 spot. You have to have a 0 here for the cube spot, okay? Now, this is what I call the, excuse me, English teachers, my adder line. It's no such word as an adder, but it's, we're going to add, okay? So I like to call it my adder line, okay? Right underneath the constant, directly underneath, I like to put a box right here because that's my remainder box.
Under the last constant?
Yeah, under the last constant. Yep, that's where I put my remainder. So here's how it works. And I like to use colors. I want you to do this all the way through. Draw a line for the first term all the way through. And the reason I like to use the arrow all the way through is you're not going to, if you do this, you won't put a number here. Agreed? Okay, so I like to bring it all the way through. Nothing goes here. So the 2 comes down. And then we're going to multiply. So we're going to multiply. We're going to multiply. So 2 times 3 is 6. So I'm going to put my 6 right here. And I add. And the reason I'm adding is because I already changed the sign. So in a sense, I am subtracting. Does that make sense? I really am subtracting, but since I changed the sign, I'm adding a negative, so I just add, and I get 6. And then I multiply. 6 times 3 is 18. And then I add. Negative 15 and 18 is a 3, right? Positive 3. And then I multiply. 3 times 3 is 9. And then I add. Negative 10 plus 9 is a negative 1. And then I multiply. 3 times negative 1 is a negative 3. And then I add. Okay, so I got an answer of 2. So this is not, I know this is not a factor. Okay, x minus 3 is not a factor. But the answer, you got to remember, we're dividing. And even though the x's are invisible, they are invisible, I did divide by an x minus 3. I really did divide by an x minus 3. So when I divide by an x, that means all of these exponents will be reduced by 1. Does that make sense? So my answer, I'm going to bring back in the invisible x's, would be a 2x cubed plus a 6x squared plus a 3x minus 1. Now the remainder, we are not in 4th grade math. We're going to go R. We're not going to go R2. It sounds like a pirate art. We're just going to go plus 2 over what we divided by, which was the original x minus 3. Remember that from last year? Okay, thumbs up. Not bad. Okay. Is this a factor? No. It is not a factor because we got a remainder of 2. Okay. Turn the page. Okay. Okay, so we can skip example 2 because that's basically what I just did. Cross that out. That's what we just did. But we know the remainder was, my remainder was 2, right? But I will do synthetic substitution, okay? So if I do synthetic substitution, if I divide by x minus 3, x equals 3. I meant to make that a 3. So if I plug 3 in, synthetic substitution, I'm going to go p of 3. So if I plug in 3, I know the answer is 2. When I plug in 3, I know the answer has to be 2. I know that. And I'm going to do it, but unless I make a dumb mistake, which I do often. But if I plug in 3, I will get an answer of 2. So if I go my 2 times my 3 to the 4th minus my 15 times 3 squared minus 10 times 3 plus 5. And Lauren, is this one you already did? You did? No, you didn't do this one, did you? I think so too. I tried to make it easy. To the 4th power minus 15 times 3 squared. Oh my goodness gracious. Already making mistakes. Try this again. 2 times 3 to the 4th power over arrow minus 15 times 3 to the 2nd power minus 10 times 3 plus 5. And before I enter, I know the answer has to be 2. It has to be 2. Boom. What is it? 2. Had to be 2. Right? Good. Okay. So here's, I think, the key that this book wants you to understand. What's the big deal about the remainder? Well, if it's 0, it goes unevenly, right? Okay. And then, like Lauren said, if that's the case and you know that, then you know already 1, 0, and then you can find others from there. Okay. So the homework today, and of course you guys are going to want to work on your balloons a little bit too, also, right? Work on your balloons a little bit.
Yes.
So let's work. It's 12. Let's work till 1 o'clock. 1:10. Let's work till 1. Let's work at least 1 o'clock. Okay.
Yeah, 1.
Let's work till 1 o'clock. Let's get some stuff done, and then we'll work on our balloons. Okay.
Are these all positions?
I hope so.